Hi everyone. In this video, we're going to take a look at how we can solve different types of equations with variables. We'll also talk about how to write an equation for a linear relationship and how to graph a linear equation as well. So kind of like some review from Algebra 1A. All right, so to start off, we're going to take a look at some examples of solving equations where we have x on both sides of the equation. So if we have x on one side of the equation, all we have to do is isolate x by undoing whatever's being done to x. For example, if we have 2x plus 1 equals 5. So we want to undo everything that's being done to x. We're adding 1, so we can start by subtracting 1, and we have to do that to both sides. So 2x equals 1 minus 1 is 0, so we undid that addition, and then we get 4 on the right side. Finally, we're multiplying by 2. So our next step would be to divide both sides by 2 to undo that multiplication. So we end up with x equals 2 as our answer to this equation. Sometimes we'll have x on both sides. What we want to do is move over some of the x terms on one side so that we end up with x only on one side. So that so we want to try and move over the x's so they're not on both sides. An example would be if we had 5x plus 2 is equal to 3x minus 8. Okay, so here we have x on both sides. What we want to do is move over one of the x terms to another side so that we only have x on one side. So I'm going to take the 3x over here. We have 3x minus 8. So because we have a 3x, another way to think about it is we're adding the 3x on that right side. We can subtract to undo that addition. So we can subtract that 3x or kind of like move over that 3x, subtracting it from both sides. So we have 5x minus 3x plus 2 equals 3x minus 3x equals 0. So that was our goal, to get rid of x on that right side. And then next we can simplify. We have two terms that have x in them. So these are called like terms, where we have the same variable raised to the same power. That means we can add or subtract the coefficients. So 5 minus 3 gives us 2x. So 2x plus 2 equals 8, or negative 8. Then we subtract 2, so we're trying to isolate x at this point. 2x equals negative 8 minus 2 gives us negative 10. And then we're multiplying by 2, so we'll divide both sides by 2. So x equals negative 5. So this is our solution to equation B. Okay, so those are some examples of how we can solve equations for x, especially when x is on both sides of the equation. I also want to talk about modeling linear relationships. So let's take a look at if you had a lemonade stand and you start with $5 in the cash register, or maybe you just have like a box that you put your money in, and then you sell lemonade for $2 a cup. So we might be asked to write an equation and then graph that equation for this linear relationship. So for this relationship, our variables are x. X is going to be the number of cups we sell. Y is going to be the amount of money we have in the register or in your box that you keep with you. So we have our two variables, x and y, and we're being asked to write an equation for this relationship. So we're going to be writing y in terms of x. We could start off with, so there's two different numbers we're looking at, 5 and 2. So notice 2 depends on the number of cups we sell, which is our x variable, whereas 5 doesn't. We just start off with $5 by itself. So we could start by just writing the 5 by itself. We start off with $5. And then every time we sell a cup of lemonade, we're going to be adding $2. So we're going to be adding on $2 times the number of cups that we sell. So 5 plus 2x would be our equation. Another way to write this is 2x plus 5. So here we identified what numbers were just kind of like a base amount that didn't depend on our x variable, and then what numbers depended on our x variable. In other words, what are we multiplying x by each time we sell a cup of lemonade? Finally, let's take a look at graphing an equation like this. 1, 2, 3, 4. Then maybe we have 1, 2, 3, 4, 5, 7, 9, 10, 11. Okay, so kind of like a quick graph. When we're graphing a linear relationship, we have two pieces of information in this equation. First, we have the number that's not associated with x. So whatever we're adding or subtracting, this is our y-intercept. So if we look at the y-axis up and down, that's where our point is on the y-axis. So plus 5 is going to be a point at positive 5. So here's 1 point on our graph. The number in front of x, in this case 2, this is our slope. So slope is rise over run. So how much do you go up on the graph each time you go 1 to the right? In this case, we have 2, which we could also write as just 2 over 1. So we go up 2 to the right 1, and then that's how we find some of the other points on our graph. So 5 plus 2 is 7, and then we go 5 plus 2 is 7 to the right 1. So positive 1, 7 is our other point. Then we go up another 2 to get to 9, and we go to the right 1 to get 2, 9. And again, we go up to 11 to the right 1 to get 3, 11. So this isn't a perfect line, but this is what our graph would look like. We would have these points, we can connect them with a line, and then draw that arrow to indicate that our line keeps on going if we sell more cups. So here we went over an example of a linear relationship, writing an equation for that relationship, and then looking at a linear equation and graphing that equation using our y-intercept and our slope. Okay, so one more part to this video. I want to talk a little bit about solving equations with squared. So how can we use square roots to solve equations where we have a squared? For example, sometimes you'll be given an equation where we have an x squared in the equation. X squared equals 9, for example. So here we want to get the x by itself, and we need to undo this squared that we see here. So the opposite of squaring something, so the opposite of squared is a square root. So in other words, this symbol, the square root symbol. So what we're going to do to undo that squared is take the square root of both sides. So the square root cancels out the squared. So we just have x. And then on the right, we have the square root of 9. One note to make is when we take the square root of both sides, so this step going from our first line in our equation to our second line, we need to make sure that we include both the positive and the negative square root. So that's what this symbol means here, positive and negative square root. So our final answers for this equation is x equals positive and negative 3. So you could write your answers like this. You could also write x equals positive 3 or x equals negative 3. So we have two answers to this equation. So often when we have a squared, we'll end up with more than one answer. And that's because if we think about this equation, x squared equals 9, we're asking what numbers can we square to get 9? So we know 3. 3 times 3 equals 9. So we could also try and think through what this equation is asking. 3 times 3 equals 9. But because when we square, if we multiply a negative by a negative, we get a positive. We also have negative 3 times negative 3 equals 9. In other words, 3 squared equals 9, but also negative 3 squared equals 9. So when we're asking what number can we square to end up with a different number, usually there's going to be more than one answer, a positive answer and a negative answer. So here, when we take the square root for this step, it's really important that we add that positive or negative so that we end up with both answers. And we only need to do this when we're undoing a squared, so when we add in the square root ourselves. Okay, so that's how we can solve an equation where you have an x squared and you're trying to undo the squared to find what x is equal to.